All right, 1991 Buick Century 3300. Intermittent no start, intermittent stall. This is a vehicle we mentioned in the previous lecture with system design. And this one has shorted injectors causing the condition. I want to show you my connections where I'm starting. I mentioned that we want to start by monitoring this reference pulse coming from the ICM, the ignition control module. So you can see my 1 volt meter lead for my scope is connected to the ICM. I'm connected to that purple white wire. That's the one that's going to give the computer the RPM signal to fire the injectors. So we're going to try to recreate this no start, and we're going to monitor that circuit. All right, this is the reference pulse with the car still running. I'm showing two things in this capture. One, this is scan data and scope at the same time. And what I've done with the scan tool, I went to a custom and I deselected everything and just picked the RPM and hit OK. So there's my scan data, just looking at RPM, and I pulled up my scope in a different window. And so this is my reference pulse, that purple white wire, that's that square wave signal. And we're looking at the computer's interpretation of that, which is the RPM at 700 RPM. So what we want to do is we want to see what these look like when the car doesn't start. One of the things you can do with no start diagnosis as far as direction is you can monitor your RPM on the scan tool while you're cranking. If you have an RPM signal, that tells you that you're getting at least an input. Crank signals coming in, but that's not a foolproof test, and I'm going to show you that here in this case where the RPM input is not foolproof. You cannot always use it. So what I'll do to prove that before the car is even an issue, what I'm going to do is a clear flood crank to keep the car from starting. I'm going to put the pedal to the floor, and that eliminates injection pulse, and we're going to watch these two and see what it does. Keep cranking. Okay, good. Was there an RPM signal? Yes, there was. Now granted, there could be a break in the wire between the module and computer, but I'm telling you, on this car, the RPM data PID during cranking was useless. So we couldn't use that one. Our reference pulse is there. This is what I want to see when we get this car to die. I want to see a good reference pulse that's as noted by this scope section right here. I want to make sure we're not losing our reference pulse. Go ahead and start the car back up, Tad. Leave it run. We'll get it hot. This car will shut down again, and we'll take the rest of this video. Now you can see our RPM signal there as soon as the car started. Just a design feature on this car. Just there isn't going to be an RPM signal during cranking. It's normal. Helps to know that you can't always use that. All right, while we're waiting for this car to die, I want to show you some of the connections I have. One is the scope voltage waveform of the fuel injector. Again, this being a group fired system, I'm on the back bank. It doesn't matter if I go front or back bank. And I'm on one of the control wires. I'm on the green control wire. And I'm going to show you what that waveform looks like on the scope with the car running. All right, so this is the injector voltage waveform. If you want to get more information on injector voltage waveforms, what they should look like, you can check out my book, Fuel Injector Testing, Fuel Injector Driver Designs. I have a nice layout of everything that's on this waveform, what it should look like. One of the things that I mentioned is that this voltage spike should be hitting at least 60 volts unless there's a Zener diode that's dumping off the spike. And you can see in this picture that we're only hitting maybe not even 20 volts on that spike. And what that's an indication of is a weak magnetic field, and that's going to be caused by a shorted injector. This system, for sure, even though the car is still running, you would be able to identify that this car has shorted injectors just by looking at that voltage waveform and that very small spike. Every single injector is going to show you the same voltage waveform because they all share the same controlled circuit. So it doesn't really help to move the voltage picture around and take different measurements. I'll show you. I'll pick one other one. And you're gonna see it's gonna be the exact same picture. That's now on the front bank. We saw no difference whatsoever on that picture. So right off the bat, we know we're in the right direction. Looking at this voltage waveform, we can take a look at some amperage waveforms with the car running. That probably helped too. And then the final view is going to be to try to catch this thing when it's actually a no start. So the next thing I'm going to show is the voltage waveform. I'm sorry. The next thing I'm going to show is the amperage waveform of each injector. You guys can watch the screen. Okay, I'm going to do some amperage checks, and what I'm going to be doing, using my amp probe, setting it on 20 amp scale, zero it, and what I'm going to do is individually go over each injector control wire, show you the amperage of each one. So I'm going to be doing this. I'm going to focus you on the scope. It's important to only do one wire, not both wires. So each injector, I'm going to be doing that down the line. I'm going to show you all 6 of these injectors. I'm going to focus you on the scope while I'm doing it. Okay, starting with the first injector. I'm set on a 2 amp scale, and we're hitting, looks like about 0.8, 0.7 of an amp. That's a pretty decent looking injector waveform. Let's look at that a little bit more zoomed. Although there's the beginnings of a straight up line right there, even on this one. That one's not too bad though. Let's take a look at some of the other ones. Moving to the next injector now. Notice the amperage went off the scale. We're gonna have to adjust that to see it. Set it to a 5 amp scale this time, and you can see on this one, we are hitting about 3 amps of current flow. Straight up line right here is indicating for sure that we have a short in this injector. So straight up line. The voltage waveform, of course, with the small spike, that's going to be lined up with all of the amperage waveforms because it's a group fired system. But straight up line indicating a short in that injector. And we're about 3 amps. That's about more than 3 times the current flow that should be on that one single injector. So that's one bad one of 6. Going to the third injector. That one's hitting about 2 amps. So again, shorted injector as indicated by the high amperage and the straight up line. So that's 2 of 3 that are bad. Going to the back bank now. And I connected my amp probe upside down. Nice feature of the Varus. Just hit the invert button. I don't have to take the amp probe back off. This one's better, but also shorted. This one's hitting just about 1 amp, maybe a little bit higher, but see the straight up line right here. So that one is also bad. Not quite as bad as some of the other ones. That's 3 bad ones out of 4. This looks like this might be my only good one. Got some noise in here. It's a bad part about amp probes in low amperage scales. You get some noise in the circuit. But what we're looking at is this ramp. That looks pretty good. Looks like I have maybe 2 good injectors. That first one we looked at though did have a little bit of a straight up line there. So one more. Final injector. See the straight up line? That's about 1.2 amps, so the amperage is high. And so basically we got 4 bad injectors out of 6. We really could say we got 5 bad ones out of 6. These Maltec ones, again, you find 1 bad one, you want to change them all. When this car becomes a no start, We're gonna try to catch it. I'm gonna go back to this front injector. The one that was really high amperage, this was our worst one. When this car becomes a no start, this one spikes over 20 amps of current flow. And it overloads the driver, shuts the car down. Interestingly enough, it seems to do it on a crank when we shut it off. Tad, go ahead, shut that off. Let's see if we can catch it. Go ahead and crank it. There it is. Keep cranking. Keep cranking. Hold up. Let's take a look at that amperage waveform. When this doesn't start, we buried the scale on a 10 amp. Try to catch it again. Go ahead. Keep cranking it. All right, good. There it was. There's our no start. We had good control. Problem was this high amperage. We're hitting about 12 amps of current flow, overloading that driver, preventing all the other injectors from firing. What I can also show you during that event, let's unfreeze this, try to catch it one more, is our reference pulse at the same time. Go ahead and crank it. See if we can catch it. Try it again. Keep cranking it. Keep cranking. Hold on. Hold on. I'm going to change my time base here, Steve. Get a little bit of detail and go ahead and crank that again. Keep cranking. Keep cranking. Keep cranking. All right, good. Thank you. Go back, take a zoomed view of that. This is our no start from a shorted injector. And you see we have our reference pulse. The big green spikes are your amperage, yellow trace is your voltage. Amperage is going near 14 amps of current. There is your no start from no injection pulse. And this is one shorted injector in particular, the one in the front, pulling everything down. That one's not firing. All the other 6 or all the other 5 are not firing. Shorted injector, no start, no pulse. Using a Noid light doesn't even flash. I'm going to show you one last thing, and that is I'm going to clip this amp probe on all of the control wires. So I'm going to take that amp probe and I'm going to access this harness back here, and what I've done is I've found the blue and the green control wires. Just going to show you the amperage that the whole system's drawing. Blue and green control. Got my amp clamp around both of them. Go back to my scope, take a look at the picture, talk about what we're looking at, and then we'll just end this. You see my green trace is my amperage waveform. And on a good system, these draw about 0.7 of an amp a piece. So 0.7 times 6, my math has been pretty poor lately, but that should be 4.2 amps. And take a look at my amperage reading here. And I'm hitting 8.23 amps at the peak of that. So that's double the current flow that we should have on this system. And of course, the car's still running, but when this car doesn't start, the one individual injector is drawing over 12 amps, and then you put on the amperage all these other ones, it just overloads the driver, shuts everything down. You put a Noid light on the system, even a Noid light doesn't light. What you're looking at in these other waveforms, the blue trace is your reference pulse. The yellow trace is your voltage pattern. Again, a small voltage spike indicates a shorted condition. If we look at this in a longer time base, You can see the characteristics I was talking about before with our 3x pulse. That reference pulse is a 3x signal. Every third pulse we get an injector fire. It's a group fire system. Fires one time per crank rotation. You are looking at that occur right there. Ignore these other dips in the yellow trace where you see that lower pattern. Those are inverted coil firing events. The coils share the same power feed as the fuel injectors in this car, and so our yellow trace, our voltage pattern, is going to show you those that interference from those ignition coils firing. And that also explains, if you were to look at just the yellow trace by itself in a zoomed in level, you're going to see some spikes in there that you may not want to see. Those just really boil down to interference from the ignition coil. So there it is right there. You can see it, that voltage spike right in here. That's just a coil firing. If I peak detect that, it even gets worse. So that spike, you got to learn what to ignore and what not to ignore. That is very simply a coil current ramp, inverted, upside down, firing at that moment in time. And you can see it on a longer time base. You see your coil firings. That's exactly what those are. In between those injector firings, those are your coils firing, and that's what happens when you share a power feed. So that's it. 91 Buick Century, shorted injectors, intermittent no start, identified by a voltage waveform, identified by a current waveform, and also a little bit of understanding on when you have good spark, no injection pulse, and knowing what could cause that condition. In this case, we were concerned with the ignition module because it was a bypass type system. It could have been that we were losing the reference pulse. We were not. Our reference was good. Can't always use the RPM data to give you direction. We went to the fuel injectors when it was a no start. We found control, but only on that one very shorted injector, overloading the driver, shutting the car off. That's it.